Alright, so hello and welcome to this demo video. Today I'll be showing you guys three simple yet educational x86 assembly language programs built using the IBM32 library. Alright, so as for the first program, it calculates the parameters of two hexagons using loop and add instructions. And as for program 2, it accepts 6 integers into an array named hello and calculates the sum of values stored at even and odd index positions, again using loop and add. And as for the third one, it combines the two previous programs and adds a main menu to prompt user to choose which programs they want to use. So throughout the demo, you'll see how we handle user input, memory access, looping logic, and output formatting, all in 32-bit assembly. Let's begin with program 1, calculating the parameters of two hexagons. I'll pass it to Wenjun to explain what the code does.
Now I will talk you through an assembly language program that calculates the perimeter of two hexagons using only the loop and add instructions as required by assessment. The goal is to interactively prompt the user to enter the side length of two hexagons. The program then calculates its perimeter by multiplying the set by 6 using a loop, and finally displays both perimeters and their total. Let's go through the program step by step. First, we include the event third tool and MC library to use base tag or functions like writing string, read int, and write doc. In the point data section, we declare all strings and the variables. For example, print 1 and print 2 are the messages shown to the user, and set hex 1 and set hex 2 will store the input values. At the beginning of the point code section, we display an introductory message to explain the purpose of the program. When the user is prompted to enter the set length of the first and second hexagon. We store those inputs and insert hex 1 and set hex 2. Next, we calculate its perimeter using a loop. Since a hexagon has 6 sides, we repair and add instruction 6 times. For perimeter 1, we add set hex 1 to EAX 6 times. For perimeter 2, we add set hex 2 to EAX 6 times. The result is stored in perimeter 1 and perimeter 2. After that, we add both perimeters and store the results in total perimeter. Finally, we display all three values using red dot. Now let's run the program. It first shows the introductory message. Then it asks Then it asks for the side length of the first hexagon. Let's enter 10. Next, it asks for the second hexagon. We enter 15. The program calculates and displays perimeter 1, 60, perimeter 2, 90, total perimeter 150, all computed correctly using loops and additions. And that's it. We have successfully created uh, uh,
Assembly.
assembly program that meets all the requirements using loop and add only and producing correct clean output. And next question I pass to Yao.
All right, thank you, Wenjun. Now that we've completed the hexagon parameter calculation, let's move on to our second assembly program. This one works with arrays and explores how to sum values at even and odd index locations. The goal is to input 6 integers into an array called hello. Then we calculate two separate sums. The sums of values at even indices, hello 0, hello 8, and hello 16 respectively, and the sum of values at odd indices hello 4, hello 12, and hello 20 respectively. So first let me explain. So an integer takes up a total of 4 bytes of space. So when 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 you want to refer to the second element, which is after the first is 0, right? So of course the second one, since it takes 4 bytes, we need to add 4, so it becomes 4, as I said just now. Then to access the third element, we need to add 4 again. So we we get 8. So in other words, to get an even index or odd index, either either only odd or even indices, we need to add 8 to the previous one lah. So for even one, we add 8 to the previous one. So 0 from 0 to 8 and 8 to 16. As for odd, get it from 4 because it starts from the second one, second element, right? 4 to plus 8, you get 12. And at 12, we get 20. As you can show, as it's shown here, lah. And then finally, both sums are displayed neatly on the screen, lah. Let's break down the program structure. First, the data section defines title and prompt messages and a hello array with space for 6 integers. There's a dupe here. The two double word variables, total even, total odd. Next, in the code section, we start by printing the title using write string. Then using a loop, ECX equals 6, because we need the loop 6 times. We prompt the user to enter 6 integers. Each one is stored sequentially in the hello array via ESI pointer here, which is extended stack what index and add ESI4. Now for the calculation, even index loop starts at hello 0, increments pointer by 8 bytes to jump to hello 8 and hello 16, as I have explained just now. Odd index loop starts at index 4, then jumps by 8 bytes each time to reach hello 12 and hello 20. These loops each run 3 times and use add total even. Total even. Add total even here. To even EX. And add odd add total odd EX to accumulate the sums. That's how the output looks like in the console. We get 20, 25, 30, 37, 40, and 43. After entering 6 integers, the result is displayed like this, right? Which makes sense because 20, right? For even one, 20 plus 30 plus 40, you get 90. And then for odd index, 25 plus 37 plus 43, you get 105. And that concludes the second program demo. Now let's move on to the third part, which is where both activities are integrated into a single menu-based application. And the menu starts, it displays a main menu called Simple Math Activities, titled Simple Math Activities. We have two choices. First one is to calculate the perimeter of two hexagons. And the second one is to calculate the sum of even and odd index values in a 6-element array. Let's select option 1, or press option 1. Program prompts us to enter the set length for two hexagons. I'll enter 5 for hexagon 1 and 3 for hexagon 2. And as shown here, the first one is 30. 6, because 5 times 6, 30. 6, 3 times 6, 18. And the total is 48, which makes sense. And then we then asked to, if we want to return to the main menu, I'll type Y to go back again. And now I'll choose option 2. Now, the program asks for 6 integers. I'll input 10, 20, 30, and so on until 60. And now, it calculates the sum of even index values for this part. 10 plus 30 plus 50, which equals 90. And then for the odd one, it sums this one up. 20 plus 40 plus 60, which equals 120, which is also correct. To end this session, I'll tap end. And the program ends with a polite thank you message confirming that all operations were successful. And that brings us to the end of our demonstration. We've started with program 1, right? Where we calculated the parameter of two hexagons using loop and add instructions. Then in program 2, we use array indexing to compute the sum of even and odd index values from user input. And finally, we brought it all together in program 3, creating an interactive main menu that seamlessly lets users choose between two activities. This concludes the demo. Thank you for watching, and I hope this has given you a clear overview of how simple assembly programs can be structured with user interaction and control flow. So that's it.